No, right? You could have one double bond. You could have, that's a mono unsaturated. You could have two, that's a di unsaturated, right? So when we remember this, we have to remember that those carbons don't all have hydrogens attached to them. So if you have 4 things around your central atom, what shape are you? Tetrahedral. If you have only, let's pick this carbon right here. If you have only 3 things, right, because this is really a CH, because he wants 4 bonds. So he's got 2 with the carbon behind him, he's got 1 with the carbon in front, and he's got a hydrogen. So how many things attached to that carbon? This is 3 things, and what do we call a carbon? What shape? Trigonal, planar, right? We only have 3 things attached. So are they going to have the same conformation? No. So those double bonds actually change the bond angles between the bonds, and they put kinks into the fatty acids. So you know fatty acids have those carbon chains, right? This is how I kind of like to think about it. And a saturated fatty acid is kind of like pages in a book. That's a terrible drawing. Awful. But do you see how they kind of fit in one another, right? Where one goes up, the other goes up. Where one goes down, the other goes down. So it's like pages of a book, right? Now, what happens if you have a double bond in there? So if we go single bond, and then we go, ooh, double bond, right? What's going to happen is you're going to introduce a kink into that chain. So now is it, you think the next chain is going to lay flat? It's not, right? You're going to have these big gaps between them. So you have to think about structurally what's going to change between a saturated and an unsaturated fat. So let me kind of clear this, right? Okay. So it is B, but I want to talk about each one. Oh, good. Y'all did really good on that. So A said saturated fats have double bonds, making them less reactive. That's not true. Saturated fats have single bonds, right? So we know that one's wrong. C, saturated fats cannot line up next to one another, so they are solids at room temperature. Saturated fats can line up next to one another, so they are solids at room temperature. They fit together very well, so they end up being solids. So it had to be B. All right, let's see. I think I like 2 more. Oh, we got a thing? This one is a double bond, yes. Okay, let's see.
I don't remember.
Say again? Okay. All right, so what kind of bonding arrangement is found in
C?
alkene? C for what? The previous one? Okay, y'all, put it on mute. If you don't have a question, put it on mute. All right, what kind of bonding arrangement is found in an alkene? I'll give you all a minute and a half. Ten seconds. Okay, so tell me, let's see what y'all picked. Oh, good, C. Now, I want to know about the other ones. If this is an alkene, what's A? Alkyne. A-N-E, not an N, N. Okay, how about B? Al what? Kyne, K-Y-N-E, and it sounds like an I. Sounds like an I. How about D? It's a ring, so it must be cyclo, and then we have single bonds, so it must be a cycloalkane. So what do you notice about the number of bonds and the letter that each of the names start with? So if you have a carbon-carbon single bond, you're an alkane. If you have a carbon-carbon double bond, alkene. And if you're a carbon-carbon triple bond, you're an alkyne, but it's a Y. So what do you notice? They're in alphabetical order. That's the way to remember it. Okay? Got to learn those tricks. Got to learn those tricks. Okay, let's go do some problems. And we'll pick up some more clicker questions on Tuesday. Okay, so we gotta go, I gotta go before 13, right? How do I go back? Whoa. All right. Here we go, 4.4. So you should be on section 4.4 and we start on 4.24, right? Am I on the right one? Okay. All right, so give the correct name for each of the following substituents. Now be careful. What is the definition of a substituent? I really wish this board were on this side because I'm left-handed. What's a substituent? It branches, C-H-E-S, branches off the main chain. And if it's carbon-based, we're going to end it in something special. So if you have carbons, it'll end in what? YL. And remember your me eat peanut butter, right? And that's 1, 2, 3, 4. Okay, so look at A. Megan, if you send me an email, I'll look and see. All right, so CH3, CH2, how many carbons? 2 carbons, so we're E, so we are what? Is it ethane, ethene, what is it? Ethyl, like the old lady, ethyl. Okay, our next one, how many carbons? 1, 2, 3, 4, so what are we? Butyl. Don't name your kids butyl. Like ethyl, not so bad, but don't name your kids butyl. All right, so how about these ones that don't have any carbon? It's just got iodine. How do we end those? Iodo. Iodo. Or fluoro, or bromo. It ends in the O. Okay. Oh, gotta go to the next page. All right, now, draw the skeletal structure for each of the following compounds. Whenever you're doing this, my suggestion is to start with the main chain. So in this, what is your main chain? Hexane. Hexane means that I have 6 carbons. And tell me about those 6 carbons. How are they bonded together? Remember, A-N-E is the beginning of the alphabet. So how many carbon bonds do we have? Just 1, so it's a single bond, right? So 6 carbons, all single bonds. I'm saying that because, oh, yeah. That's right, Abigail, you're right. I'm gonna go in and I'm gonna delete that one. So don't worry about it. I'm gonna go in and delete it once the class is over, but good catch. Okay, so we have 6 carbons, they're all single bonds. What about the 3-ethyl part? Tell me in words what it's gonna look like. On the 3rd carbon, you have an ethyl group, but what's an ethyl group? 2 carbons. So I'm going to write it as I have a CH3, CH2, and that CH2 is bound to something. So you could have written it the other way. You could write CH2, CH3, but you got to be careful of where you put the line, where you're connecting that substituent group. So whichever one's connecting to the main chain, it has one less hydrogen. And Chelsea, if we have time at the end, I'm going to add some more clicker questions. We'll see how far we get. Okay, so let's draw our 6 in a row, right? So it's 1, 2, 3, 4, 5, 6. So I'm going to number them 1, 2, 3, so 3, 4, 5, 6. So I have 6 carbons. They're all single bonds. We got that. Now on the 3rd carbon, we're going to have 2 carbons coming off of it. So how are you going to draw that? One coming down and then put it at an angle. So that's showing me I have 1 carbon here and 1 carbon here. Okay, let's do B. Tell me about B. Pentane, just tell me about pentane. Pent is 5 sides, like the pentagon, 5 sides. So we have 5 carbons. What kind of bonds? Okay, now, what does the cyclo tell us? In a ring, okay? Now we gotta worry about our substituents. We have on carbon 1, we have what? You have Br, bromine. And then on carbon 3, you have what? Iodine. I kind of like to write out what I'm going to draw before I draw it. It helps me to make sure I'm going to draw the right structure. So I need to have 5 carbons all in a ring. I'm still not a good artist at this. I'm, just never been good at drawing. All right, so I have 5 carbons. Does it matter? I want to put them on carbon. I want to put my bromine on carbon 1 and my iodine on carbon 3. But does it matter where I start my numbering? No, it doesn't matter. So start anywhere you want, whatever floats your boat. 1, 2, 3, 4, 5. Okay, so off of carbon 1, I have bromine, and then off of carbon 3, I have iodine. I'm going to tell you where a lot of people make a mistake because I don't want you to make this mistake. If I'm looking at this ring, you just built it. But a lot of people will look at the ring and say, I have 1, 2, 3, 4, 5 carbons here, and then 6, 7 total carbons. Is that right? No, why? The line is leading to another element. It's not leading to another carbon, right? So that line just tells you that you've made a bond with another element, not that there's another carbon there. If there's no element there, you can assume it's a carbon. But if they write iodine or bromine, then you know it's another atom, okay? All right, last one. Propylcyclopentane. So tell me about pentane. 5 carbons. It's cyclo. They're all single in a ring. What else do we know? Propyl. Which carbon am I going to put it on? Carbon 1. There's nothing listed. So you automatically just put it on carbon 1. We have propyl. So remember, me eat peanut butter. How many carbons? 3. You have, so bond CH2, CH3, CH2, CH3. Okay. So when I draw this, I'm going to draw my same ring, 5 carbon ring. Now, does it matter where my carbon 1 is? It doesn't matter. I only have one group. So I'm going to put it coming off. So that's 1 carbon. Then what? 2 carbons, 3 carbons. Okay, good. All right, next page. Now we're going to go in reverse. We're going to look at a structure and we're going to go to a name. So give the correct IUPAC name for each of the following compounds. And you're only responsible for IUPAC names. You're not responsible for common names. You just have to know the normal naming system. Okay, so how many carbons do we have? We have 3 carbons. And we have a ring. What are we going to name it? Me eat peanut butter, right? So this is a cyclo because it's a ring. And then 3 carbons is what? Propyl or propane, right? So pro. And then it's all single bonds, so it's propane. Okay. Look at B. B, you first have to figure out what's my longest chain, right? So when you're trying to find your longest chain, if you use your finger and you trace it until you get to the end, without picking up your finger, the maximum number of carbons you go through is your main chain. So if I start drawing and I go this way, right? I want to go my longest path without picking up my pen. So how many carbons did I go through? I went through 6 carbons. So what do I know about my parent chain? 6 is hex. And do we have any double bonds or triple bonds? So it's hexane. Okay, now what do I have to worry about? I have 3 substituents. What is my F? Fluoro. And what are these, both of these? These are methyls. So when I write this, I want to write my fluoro first because I need to put my substituents in alphabetical order. So when I put them in, I'm going to want to put fluorine first. So I want to say fluoro something methyl hexane. I don't want to say something methyl something fluorohexane. I want to say the fluoro first. So with my numbering scheme, does that work? No. So I'm going to have to change my numbers. So how should I do that? I should start numbering from the other end, right? 1, 2, 3, that's a 2, doesn't look like a 2. 4, 5, 6. right? So now my fluoro is on 3. So that's 3 fluoro. Where are my methyls? 2 and 5. And because I had 2, I'm not just going to say methyl, I'm going to say dimethyl. So 3 fluoro, 2,5-dimethylhexane. Get some crazy names, it can. But if you know what it means, it's not too bad. Okay, so our next one. How do I know if I'm going to name my ring as the parent or a substituent chain as the parent? I'm looking for my longest chain of carbons. So is my longest chain of carbons in the substituents or is it in the ring? It's in the ring. It's in the ring. So what are my substituents? They're all methyls. So does it matter which one's first? It's all the same letter, but we want to give it the lowest numbering scheme possible. So where should I start my numbering? What if I start here? 1, 2, those are low. 3, like I could count, that would be great. 3, 4, 5, 6. Is that the lowest way that I can count? No? What should I do? 1, 2, 3, 4, 5, 6. So I'm going to go with my blue numbers. So that means I have a methyl at 1, a methyl at 2, and a methyl at 4. So I'm going to call that 1, 2, 4 trimethyl. And then what's my parent? It's a ring, so it's cyclo. And then it's still 6, just like the last one, hexane. So 1, 2, 4 trimethylcyclohexane. Okay. All right, so we're next going to do isomers. Remember, when you're comparing, you want to find out, is it a conformational isomer or is it a structural isomer? In order to be the same compound, we have to have a molecular formula that's the same. So if their molecular formula is not the same, they're not related. But if their molecular formula is the same, they could either be conformational isomers or structural isomers. If they're conformational isomers, their atoms are connected in the same way, like I still have my arms connected to my body, I can just kind of move them, right? That's a conformational isomer. But a structural isomer, you would take my arm and put it where my leg is and put my leg where my arm is. It wouldn't be the same, right? It wouldn't be the same molecule, okay? So it would be a different structure. So how are you going to know that it's a different structure? Well, my arm is a particular substituent and my leg is a particular substituent. So I would name it differently because it's in a different place. So let's check that out. Let's see if we can do that. Oh, and I gave lots of room. I tried to give lots of room on this one. Okay. So let's look at A. How many carbons are in the chain? 4 carbons on the left. How many carbons on the right? Do they have the same number of hydrogens? Yes, they do. Because carbon 1 over here is CH3, carbon 2 is CH2, CH2, CH3. So what's my formula? C4H what? right? 3 on either end, so that's 3, 6, 7, 8, 9, 10. So let's do here, C4H10. So are they isomers? Yes. Now the question is, are they structural isomers or conformational isomers? The way that you figure this out is if you name them differently. So let's name the skeletal structure on the left. How would we name that one? If we have 4 carbons, right? Me, eat peanut butter. 4 carbons is butane. There's no double bonds, right? There's nothing coming off of it. We don't have any substituents. How about the next molecule? What do we name that one? Butane. So if they are different molecules, they're structural isomers. If they're the same molecule, they're conformational isomers. So what kind of isomer is this? Conformational. They're the same molecule. Okay, let's do the next one. Let's count our carbons. So I'm going to count my ring first. 1, 2, 3, 4, 5. And then I have 6, 7 as substituents. Let me do the other one. 1, 2, 3, 4, 5, 6, 7, 8. Do you see a red flag? Yep. What can you tell me about these 2 molecules? They have different numbers of carbon, so are they going to have the same molecular formula? No. So tell me about these. Are these isomers? No. So we say they are not related. So you don't even have to worry about the hydrogens, right? If this one is C7 and this one is C8, automatically you know that they're not related. Okay, let's try the next one. Remember, when you're numbering your carbons, you want to find that longest chain possible. So I'm going to start up here at the top. 1, 2, 3, 4. So that's my main chain. And then I have 1 extra carbon. So that would be my 5th carbon on my substituent. So now I'm going to do the same thing over here. 1, 2, 3, 4. And then I have a substituent, so that substituent is carbon number 5. Do we have the same number of carbons? Yes, we do. Are we the same molecule? Let's name it. Let's name it. If I have 4 carbons in a row, what do I call it? Me eat peanut butter, butane. That's all you're going to know when you walk out of here today. Me eat peanut butter. Okay. Now coming off of carbon what? We have something. Carbon 2, we have a what? A methyl group. So this is 2-methyl-butane. And I guess that B really should be lowercase. I think your homework is picky about cases. So put everything lowercase. Okay, the next one. I have 4 carbons in a straight chain. Do I have any double bonds? Nope. So what do we call this one? Same thing, butane. What carbon is my methyl group attached to? 2. So what kind of isomers are these? These are conformational. Isomers. D, our first skeletal structure. How many carbons are in our main chain? 5. Okay, and the next one, how many are in our main chain? Ooh, so we got a difference there. So we have a substituent, and this substituent makes 5 carbons. So they have the same number of carbons, but are they arranged in the same way? No. So this is like taking my leg and putting it up here where my arm is, right? So how would you name the one on the left? I'm going to prove it to you. 5, what prefix? Pentane. We don't have anything coming off of it. What's 4? Butane. But I have something coming off of carbon 2, and it's a methyl group. So I have 2-methyl butane. So I end up having to name them differently. So these are structural. Okay, E. What's your red flag here? We have different substituents. So even if your carbons are the same, 1, 2, 3, 4, 5, what are you going to have? Different names, because we have different substituents. So you don't have to go count hydrogens. We just know bromine and chlorine are not the same atom, so it can't be the same molecule. So what are these? Not related. Not related. Okay. All right, I think we only got one left. We're talking about cis and trans stereoisomers. So we're going to look at a picture and we're going to try to draw a cis and trans stereoisomer for each molecule. Do you remember when we wanted to indicate something going into the screen versus coming out at you, what we did? We did the solid triangle, or we did that dashed triangle. It's the same thing. You can go in and out, or you can go, guess what? Up and down. So, and it doesn't matter which one you do. It does not make a difference. So draw your main structure, right? Now I want to draw the cis isomer first. In order to draw my cis isomer, I have to look at my substituents, and I want to put them on the same face or the same side. So I want them to go out. So I'm going to make a solid. So that's my 1 carbon. I also want to make, I went the wrong way, didn't I? Right. I also want to make this a solid triangle. But it's not just 1 carbon. This one is 2 carbons. So this one is on the same, this is cis. Could we have done it a different way to draw a cis isomer? We could have drawn them both as what? As dashes, right? So you could have done right? And add your thing right there. Both of these are cis. What if I want to do a trans? There are 2 different ways to do this one too. Let's keep the cis, let's keep this one the same, this methyl group the same, but let's change our ethyl group. You just make them opposite. So trans isomers. So one's going down, one's going up. So you take the plane of the ring and then you make the substituents go either direction. Tell me about B. What's different about B than A? They both have 2 substituents, but they're on the same carbon. If your substituents are on the same carbon, there's no cis or trans. So see in the instructions, it says for those that can. So you just write not possible. Because they're on, because substituents are on the same carbon. Okay, how about this one? This isn't a ring anymore. What is this? A double bond. So you draw your like imaginary line through the double bond and you look what's attached above and below the line. Well, really, you have a hydrogen here and a hydrogen here and a hydrogen here attached to these carbons. So how many substituents do you actually have? Is a hydrogen a substituent? No. So how many substituents do you have? Only one. So again, not possible. But this time, because you only have one substituent. And our last one, I'm going to rewrite so that I can see my structure. I have my two carbons that share the double bond. I'm going to look at my blue carbon first. My blue carbon has a hydrogen attached and it has this group. So it has a CH2 and that's bound to a CH3. And then my red has a hydrogen and it has a fluorine. So if I draw my imaginary line, tell me what kind of an isomer did I draw? Is a cis or a trans isomer? It's cis because look, they're on the same side. Hydrogen's not a substituent, but everything else is. So these are on the same side. So these are, whoa, it's my watch. I figured it out, it's my watch. No. Where were we? Well, here. These crazy H's. What? Okay, why do you not like that? You like delete. You don't like backspace. Okay, so they're on the same side. So now if I wanted to do my opposite, and I want to do a cis isomer, I'm going to put this group on the same place, but I'm going to change my other group. So I'm going to have a hydrogen. So what I'm going to do is I'm going to swap it. I'm going to put my fluorine up here, and I'm going to put my hydrogen down here. So what do I have? If I put my dotted line, I have a group down below, I have a group up above. So this is trans. This one is cis. Were there other ways to draw cis for this molecule? How else could you have done it? You could put both the CH3, CH2, and the F on top. That would have been okay. And then for the trans, if you had swapped them, if you had put the CH3 up here and the fluorine down here, that would have been okay. As long as they were on opposite ends. Okay? All right, we got one topic left. Only one left. All right, chirality. Chirality. So we did that page on the video. So before we start tackling this, give me the definition of a chiral center. It's a carbon bound to 4 different things. The key there being different. So before we try to go in and analyze all these molecules, I want you to tell me what's not chiral. And make sure you write this like not chiral. CH. Come on. Chiral. So not chiral. So give me an example of something, a carbon that's not chiral. CH3. Well, it can't be CH4, but I guess technically CH4 would not be chiral. You're correct. CH4 would not be chiral. But you're not going to see that in a big compound, right? CH2 is not chiral because what two things are the same? You get two hydrogens. If you have one hydrogen, could you be chiral? You could. Doesn't necessarily mean that you are, but you could be chiral. What's another example of something that is not chiral? Got one more. Any bond greater than one. So a carbon-carbon double bond or a carbon-carbon triple bond. Yes, good. Double bond. And then, oh, I did kind of miss one. I did leave out one. Anything that's not carbon, right? Elements that are not carbon. So this is your little cheat sheet. So you know what's not chiral. Then it's going to be easy for us to go in and eliminate the things that are not chiral. And what you're left with are the chiral atoms. All right, so I'm going to say blue. I'm going to use blue to cross out things that are not chiral. And then I'm going to end up putting an asterisk, a red asterisk for chiral things. So how about my oxygen here? Chiral or not chiral? Not chiral, it's not carbon. So it can't be, right? So that one's not. What else? I'll just put an X on it. How about my carbon at the top? This carbon right here. Is it chiral? Why not? It's got two hydrogens, so it can't be chiral. What else? Let's go down one. Let's go down to this carbon right here. Is this one chiral? So let's look at it. It's got a CH2 and OH. Then it goes into the ring, which is an oxygen going that way, and then a carbon down here that's got an oxygen, another carbon, right? So what else is on this carbon right here? A hydrogen. Do I have 4 different things attached to that carbon? Absolutely, I do. So I'm going to mark that one as chiral. Okay, let's go down the chain. Let's go to our next one. Let's go to this one. Oh, that's cool. I didn't know I could do that. Whoa, that's a little bit scary. Oh, please let me write. All right. Okay, so how about this next carbon right here? Does it have 4 things attached to it? I didn't actually draw it, but it does. I have to put those hydrogens in to satisfy the octet, unless I see that it's a double bond or a triple bond. So does it have 4 different things attached to it? And this carbon down here has an OH bound to it. Does it have 4 different things attached to it? Yes, it does. Absolutely, it does. Do we just look at the next atom? Do we just say, here's a carbon, so it's not chiral? Do we just look at the next atom? No. You have to look at everything attached to it. Okay, so let's do the next one. Let's do this carbon right here. So we have an OH coming off of it. We go across to a carbon, to an OH, right? And we must have a hydrogen on it. Is this one chiral? Yes. Can you give me a guess for the next two carbons? Yes, they are. Because each of the carbons has some other group coming off of it, and the ring is not symmetric because of this oxygen right there. So you have 4 chiral centers in this one. All right. Next one, panthenoic acid, vitamin B. All right, which ones can I eliminate right off the bat? I wish I could easily zoom in, but I don't really want to mess it up. Or zoom? I don't know. Okay, we'll just figure it out. So, which ones can I eliminate on this structure? The double bonds. So these carbons, because it's really a carbon double bond to an oxygen, OH, and then another C, right? This N one. So there's only 3 things around it, so it can't be chiral. Okay, so those are eliminated. We know nothing that's not carbon. Tell me my next carbon in. Is this one chiral? What's actually attached to that carbon? I only see 2 things attached to the carbon, right? 1, 2. Does that satisfy the octet? No. So what is that carbon actually? Yep, this is actually CH2. If you're CH2, right, because I have this carbon, and it's got a bond and a bond, so that must mean that there are 2 hydrogens also attached to it. Tell me about those 2 hydrogens. They're the same. So is it chiral? No. So let me kind of clean that up. So we said this one was not. We said this one was not. Go to the next carbon. Tell me about the next carbon. It's also a CH2. Very good. So if it's a CH2, not chiral. Then the nitrogen. The nitrogen is not carbon. So moving on, right? Then we have the carbon double bound, so it's not that one. Okay, so how about the next one? Let me erase this. We have a carbon, and it's got that wedge, and it's got the OH, and it's got this coming off of it. Does it only have 3 things around it? No, it actually has a hydrogen. On either side, is it the same stuff? Carbon double bound to an oxygen on this side. Oh, this is, no, it's not the same, right? So this one, yes, can be a chiral center. Okay, let's do our next carbon. We have a carbon, it goes up this way, it goes up that way, this and this. So that goes to a carbon, that's a carbon, that's a carbon, that's a carbon, right? Is it chiral? Because this is really a carbon bound to an oxygen and a hydrogen. This carbon has the OH on it, right? And then this carbon down here has a what? CH3, and this one is a CH3. So is this central carbon right here chiral? Okay, another carbon, double bound to an oxygen. You keep going. It's not chiral. Why is it not chiral? It is not chiral. Good. Because these 2 groups are the same. They're exactly the same. So this carbon cannot be chiral. How about the 2 carbons that I just circled? This one and this one. Are they chiral? No, because they're CH3s. So those aren't chiral. How about the next one in line? Why not? This would be a CH2, so we can X that one out. And then next in line is an oxygen. So how many chiral centers do we have? Only one. Only one. If I can erase some of this. Okay. In this one, I want you to look and automatically see some double bonds and go, that is not cool, right? So if they got double bonds, you can't be chiral because you don't have 4 things attached. So go in and look at all the carbons that have a double bond attached to them and X them out. Let's see, come over here, we got some double bonds here, we got a double bond there, we have a double bond there. You eliminated a lot of stuff just by looking at double bonds. So let's come in from the left, and we're gonna go from left to right. We're gonna look at carbons. So this one that has the NH2 attached to it. And then we have a ring on that. And then we have this. Okay. Are these all the things that are attached to the carbon? No. We also have a hydrogen. Is the carbon chiral? Are any 2 substituents off of that carbon the same? No, they're not the same, so it must be what? That one's chiral. Be careful with your X's and asterisks. I don't know how to say that properly, but be careful. All right, let's go to the next one. Let's see, nitrogen is not chiral, but then there's a carbon right there. So tell me about that carbon. So we have a carbon. It's bound to a nitrogen with a hydrogen, right? And then down here it goes to a carbon double bound to an oxygen. Across here, carbon with a hydrogen. What are we missing? A hydrogen. Is it chiral? Yes, it is chiral. There are no 2 groups that are the same, so yes, it is chiral. Okay, we're going to go over one more. Let me erase this. Okay, we're going to go over one more. We have a carbon, we got a hydrogen, a carbon that goes into a ring, a nitrogen, a sulfur. Anything the same? Are any groups the same? Nope, no same groups. So what can we say? Must be chiral. Okay, we know that sulfur is not carbon, so it's not chiral. How about this next carbon right there? What is that next carbon? Really, it's CH2, so it can't be chiral. We all have one more carbon. This one right here. Is it chiral? Why not? Because it's really a CH3. So how many chiral centers do you have? 3. All right, last one. I guess I'll leave that right there. Okay, so what can we eliminate first off the bat? Carbon is attached to a double bond. We know it doesn't have 4 things, so we can get rid of it. Okay, tell me about this first peak over here, this carbon. This is really a CH2. Well, what does that make the other one? A CH2. Can't be chiral if you have 2 hydrogens. Do you have any chiral centers? No chiral centers. Good. Oh, look, we're at 48. We finished in time. All right. Any questions? So this is the end of the exam material, and your exam will be in 1 week. So your homework, you have chapter 3 due tomorrow night. Then you have chapter 4 due Monday night. And then you also need to watch chapter 5, section 1 lecture that I don't know that I've posted yet. I didn't post it yet. I need to go post. Okay, I will go post. All right. If you have any questions on the chat, let me know. Sure.
So this is for 5 carbons.
Yes.
But if this didn't have anything, that would be 6 carbons. Like say the bromine wasn't 6.
Correct.
Okay.
Correct. If you end a line and you don't put an element, you can assume it's carbon.
Okay.
But if you have a line and it ends in an element that's not carbon, then it's a bond between the carbon and that element.
Okay. Thank you.
Yeah, no problem. That's a great question. What will we do on Tuesday? On Tuesday, we are starting chapter 5. On Tuesday, we are starting chapter 5. So we'll have the first half of chapter 5 on Tuesday.
I don't know how to do homework and how to, like, what should I call it?
Oh.
Not graph, but like draw everything.
Did you watch the tutorials?
Yes, I did.
Okay.
But partly because I don't know how to do it. Like in general, not
It's okay.
just drawing.
All right,
Oh,
let me
this
see.
one's just
Does
drawing.
anybody have, I'm going to end the chat so that I'm not doing a really long recording. Anybody else on the chat have any questions? Is there a way to make up the first 2 questions? Oh, great. No, I'm sorry. There is not a way to make up the questions, but that's why I give y'all a wide range in the beginning. So at like a 70% to 100, you still get the maximum points so that you can miss a day, you can have a technical glitch, you can have something happen and you're still covered. Okay. Anybody else on the chat? Good, good. Okay, Caitlin. Anybody else on the chat with a question? Okay, if you still have one, you can go ahead and send me an email and I will help you out, but I'm going to go ahead and end the recording. All right, y'all have a great day.